This video, we're going to cover the problems from the Algebra 2 review, the Killer Algebra review worksheet for those preparing to go into Calculus 1 with analytic geometry. There's roughly 70 problems on this worksheet, a little bit more than that. So this is going to be one of the longer videos in the series. The first problem, negative 210 over 30 times 30 over 7. The 30s will cancel to make a 1. 7 goes into 210 30 times. It's a negative divided by a positive. So remember, this is a negative. The answer is negative 30. Number 2 is 14 over 20 divided by 28 over 10. We're going to rewrite that as 14 over 20 divided by 28 over 10. So we can write it this way with multiplication. 14 over 20 times 10 over 28. 14 goes into 28 2 times. 10 goes into 20 2 times. A half times a half is a quarter. Number 3. Add or subtract 7 over 40 minus 1 over 50 is going to be 5 times 5, 5 over 5, and 4 over 4. I make denominators of 200. This is 35 minus 4 over 200. It's going to be 31 over 200. How did I know that 200 was the least common denominator? I'm going to take 40 and 50 and factor them. So my LCD has to contain 2s and 5s. I have to have the least amount or the most amount of 2s. When I choose 2s from here, there's 3 2s and 1 5. Or over here, there's 1 2 and 2 5s. So I'm going to be greedy and I'm going to take my 2s from the 40. There's 3 2s there. Be greedy and I'm going to take my 5s from 50 because there's 2 there. 8 times 25 is going to be 200. You can always find your LCD that way with a factor tree. I think I missed a negative sign there. Really doesn't matter, but let's go back and do it again. This was negative 35 minus 4 over 200. Should have been negative 39 over 200. That's a negative 7 over 40. 2x plus 2 over 10x squared plus 16x plus 6. We're going to reduce by factoring. So first thing I'm going to see is that there's a common factor of 2 there. There's a common factor of 2 here. It's going to cancel. We're not done yet. And we've simplified it and written it in lowest terms. Four minus k squared over k squared minus 5k plus 6. We usually like to have things in descending order of exponents. So I'm going to pull that negative out front. And we're done with that. Moving on to number 6. We use our factor by grouping technique that we talked about in the last video on this numerator that's 4 or more terms. This is a perfect square trinomial on the bottom, so it is the same factor times itself. That be w plus 6 times a w squared plus 4. There's a w plus 6, another w plus 6, w squared plus 4 over w plus 6. That's it. Number 7, we have z squared plus 20z plus 100 over z squared minus 36 times z squared minus 6z over z plus 10. I didn't make mention of this before, but I put lines through my z's because my 2's and my z's look so similar. So this is going to be z plus 10 times z plus 10 over z plus 6, z minus 6 times z minus 6 over z plus 10. Z plus 10 will cancel. Z minus 6 will cancel. We're going to be left with z times z plus 10 over z plus 6, and we'll be done. X squared plus 2x minus 3 divided by x squared minus 6x plus 5 times x minus 5. Give me x plus 3 times x minus 1 times x minus 5 over x minus 1 times x minus 5 minus x plus 3. Now we've got x squared plus 7x plus 10 over x squared plus 12x plus 35. Big division bar, x squared plus 2x over x squared plus 9x plus 14. We're going to rewrite that horizontally. We're going to multiply by the reciprocal. I'm going to do that all in one step here. So that's the same problem we've written. Go into now start factoring. X plus 2, x plus 5, x plus 5, x plus 7, x plus 2, x plus 7, x times x plus 2. And we are left with x plus 2 over x. Number 10, we have x cubed plus 1 over x cubed minus x squared plus x divided by negative 56x minus 56 over 8x. Again, we're going to rewrite that. X cubed plus 1 over x to the third minus x squared plus x times 8x over negative 56x minus 56. Now work with it in that form. This is x plus 1 times x squared minus x plus 1. We talked about how to factor a sum at 4 different cubes in the last video. So x plus 1. So we have x plus 1. We have x squared minus x plus 1 cancels out. X cancels out. 8 goes into negative 56. Negative 7 times. So this is negative 1/7 for my final answer. Add or subtract is indicated. I have to find a common denominator first. So I see m plus 2 is already in common. This one over here needs m minus 6. This one here needs m plus 5. So this is m minus 6 times m minus 2 plus m plus 5 times 4m plus 1 all over m minus 6, m plus 2, m plus 5. My numerator is going to be m squared minus 8m plus 12 plus 4m squared plus 21m plus 5 over m minus 6, m plus 2, m plus 5. Four m squared plus m squared is 5m squared. 21 minus 8 is 13. 12 plus 5 is 17. We're not going to be able to factor that numerator anymore, so we are done with number 11 now. On to number 12. Three over, this is going to be y minus 1, y minus 2, plus 7 over y minus 1, y plus 1. This one's missing y plus 1. This one's missing y minus 2. This will be 3 times y plus 1, plus 7 times y minus 2 over y plus 1, y minus 1, y minus 2. 3y plus 7y is going to be 10y. 3 minus 14 is going to be negative 11. Y plus 1, y minus 1, y minus 2. Numerator won't factor anymore to be able to cancel out with anything. Always make sure, though, that when you add or subtract fractions, that your numerator can't factor and cancel out with something in your denominator. Make sure you're writing your answer in lowest terms. Number 13. 5 over x plus 5 plus 15 over x plus 7, all divided by 2x plus 11 divided by x squared plus 12x plus 35. This one tells us to use method 2. So method 2 means to clear the fractions. That if I take x plus 5 times x plus 7, I get x squared plus 12x plus 35. So I'm going to multiply top and bottom of the fraction by x squared plus 12x plus 35. This is going to give me 2x plus 11 in my denominator. When I multiply each term here, you can see it more clearly. X plus 5 times x plus 7 plus 15 over x plus 7, x plus 5, x plus 7. That's the same thing. It's what I was doing just a second ago, that this is going to be 5 times x plus 7. It's 15 times x plus 5. And then I'm going to have 5 and 15 makes 20. 35 and 75 makes 110. 2x plus 11. Not done. I warned you about this just a second ago, that I see a common factor of 10 in the numerator. And it simplifies to be 10. Use the product rule to simplify these square roots now. The fourth root of 80, x to the 6, y to the 10. They tell us specifically here that x can be any real number. So when I have an even root, and I have an odd number of x's come out of it, I have to put absolute value bars around it. So for instance, this is going to be absolute value of x, but I'm going to have 2 y's that are going to come out. So that's going to be a y squared. So I don't need absolute value bars around that. Inside here, there's going to be 2 x's left, and there's going to be 2 y's left. Now, with 80 is 2 times 40, which is 2 times 20, which is 2 times 10, which is 2 times 5. There's 4 2's right there, so the 2 comes out, and the 5 is left on the inside. This is 2 times the absolute value of x times y squared times the fourth root of 5 x squared y squared. The main thing here is this absolute value of x that we got because when we took one group of 4 out from the x to the 6, they had to be positive on the inside. We didn't want to accidentally allow it to be negative. When we brought it out, we have to put absolute value bars on the inside. On the outside, excuse me. So now we're going to have the 8th root of x minus 4 to the 8th. And it's the same thing here. It's an even root. When I divide the exponents here, I get an odd power. So I'm going to have the absolute value of x minus 4. Now we're going to simplify the expression 4 plus root 8 over 2. It's going to be 4 plus 2 root 2 over 2 is 4 over 2 plus 2 root 2 over 2. 4 divided by 2 is 2. 2 divided by 2 is 1. 2 plus root 2. Trying to add or subtract these roots. We have 7/9 underneath the square root sign plus 343 over 25 under a square root sign. So this is square root of 7 over 3 plus 11 root 11. No, not 11, 7, excuse me. 7 root 7 over 5. 7 times 7 is 49, times another 7 is there's 63, 28 plus 6 is 34, 343 is 7 cubed. So we need to multiply this one by 5 over 5, this one by 3 over 3, so we get a common denominator of 15. 5 root 7 plus 21 root 7. It's going to give me 26 root 7 over 15. Only factors of 15 are 3 and 5. Neither of them go into 26. So I'm done. Solve the equation m minus 7 over m equals 6. So I know that m can't be 0 because of my domain here. I'm going to multiply both sides by m. M squared minus 7 equals 6m. M squared minus 6m minus 7 is equal to 0. And minus 7, m plus 1 equals 0. M minus 7 equals 0, or m plus 1 equals 0. M equals 7, or m equals negative 1. You want to check your work here. Wouldn't be a bad idea. 7 minus 1, is that equal to 6? 6 is equal to 6. Negative 1 plus 7, is that equal to 6? 6 is equal to 6. So both are correct answers. Okay. X minus 6 over x is equal to 35 over x plus 6. We know here that x can't be 0 or negative 6. We're going to go ahead and cross multiply. X squared minus 36 is equal to 35x. X squared minus 35x minus 36 is equal to 0. X plus 1, x minus 36 is equal to 0. X plus 1 equals 0, or x minus 36 equals 0, x equals negative 1, or x equals 36. Check those answers if you would like to. Negative 7 over negative 1, is that equal to 35 over 5? 7 is equal to 7. Check 36. 36 minus 6 is 30 over 36. Is that the same as 35 over 42? This reduces to be 5 over 6, and this reduces to be 5 over 6. So both of those are true. Move on now to number 20, 1 over z plus 6 plus 3 over z plus 4 is equal to negative 2 over z squared plus 10z plus 24. I'm going to, just like I've been doing with the other ones, say z can't be negative 4 or negative 6. I'm going to multiply by this denominator, though, the common denominator here of z squared plus 10z plus 24 is going to wipe out my denominators. This is method 2 that we were talking about before. To a negative 2. So this is z plus 4 plus 3z plus 18 is equal to a negative 2. 4z plus 22 is equal to negative 2. 4z is equal to negative 24. Z is equal to a negative 6. Z is not allowed to be negative 6. That violates the domain. So there's no solution to this problem. See that? Okay. Three over x minus 3 quantity squared plus 3 over x minus 3 is equal to 30. I'm going to do something strange here. Okay, just to teach you about it. I'm going to let u equal to 3 over x minus 3 and rewrite this as u squared plus u is equal to 30. So u squared plus u minus 30 is equal to 0. This is u plus 6 times u minus 5 is equal to 0. U plus 6 equals 0, or u minus 5 is equal to 0. U equals negative 6, or u equals 5. What was u equal to? U was 3 over x minus 3. So I'm going to come back and make that back substitution. 3 over x minus 3 is equal to negative 6, or 3 over x minus 3 is equal to 5. Going to cross multiply. 3 equals negative 6x plus 18, or 3 equals 5x minus 15. I'm going to subtract 18 and get negative 15 equal to negative 6x, or we're going to add 15 here and we're going to get 18 equals to 5x. Divide, x equals negative 15 divided by negative 6 is going to be a positive 5 over 2 when I divide top and bottom by negative 3, or x is equal to 18 over 5, and that doesn't produce anymore. Didn't have to do it that way. I just wanted to show you u substitution because u substitution is going to be helpful in some of the other problems that we're going to be doing. Whenever I see a repeated ugly looking thing in the problem, or could help me to stick a dummy variable in for that, I'm going to do that. Now we've got, oh, and by the way, with this last one, I didn't state the domain explicitly before, but we know that x cannot be equal to 3 here. That would give us undefined fractions here, and we did not have an issue where x was equal to 3. I would recommend that you go back and test these, but I'll let you do that on your own. Now for number 22, 4x plus 1 inside of a square root sign plus 2 on the outside is equal to 0. We're going to have a problem. 4x plus 1 is equal to a negative 2. I don't think so. There's no solution to that because I shouldn't be able to take a principal square root here and get a negative answer. So there's no solution to that. Let's try number 23 now, which says root 2x plus 8 equals x plus 4. So I'm going to isolate the square root by subtracting 8 from both sides. Root 2x is equal to x minus 4. I know my domain of this is going to have to be the x is going to have to be greater than or equal to 0 because of that square root in the problem. Now I'm going to square both sides. I'm going to get 2x is equal to x squared minus 8x plus 16. I'm going to subtract the 2x here. We're going to get 0 is equal to x squared minus 10x plus 16. Factors of 16 that add to be 10 are going to be 2 and 8. It's x minus 2 and x minus 8. So x minus 2 equals 0, or x minus 8 equals 0, x equals 2, or x equals 8. Let's quickly just check them out. 2 times 2 is 4. Square root of 4 is 2. 2 plus 8 is 10. Is that the same as 2 plus 4 is 6? No, that's not true. 2 times 8 is 16. Root 16 is 4. 4 plus 8 is 12. 8 plus 4 is 12. So sometimes when I change the domain by squaring both sides like this, I add extra what we call extraneous solutions. So especially when I have square roots of my problem like this, and I square both sides, I need to go back and check my answers because the only real answer to this one was x equals 8, x equals 2 was extraneous. Okay. Now we're going to solve the system of equations. X squared plus y squared equals 85. X plus y equals 13. Use whatever method I prefer. Okay. If I square both sides, no, that's not really going to help me. So I would probably use graphing here. But I do that with something like the Desmos graphing calculator that's going to show me the points of intersection. Since I'm not doing that right now, then I'm going to square both sides of x plus y. I will do this and make this into x squared plus 2xy plus y squared equals 169. And then I'm going to subtract the first equation. That's going to give me that 2xy is equal to 84. Now I'm going to solve for either x or y. I don't care which here. Y is equal to 13 minus x, let's say. So if y is 13 minus x, then 26x minus 2x squared is equal to 84. 0 is equal to 2x squared minus 26x plus 84. This is 2 times x squared minus 13x plus 42. Factors of 42 that add to give me 13 are 6 and 7. It's x minus 6, x minus 7. So this is x minus 6 equals 0, or x minus 7 equals 0, x equals 6, or x equals 7. I'm going to come back to x plus y equals 13. So if x plus y equals 13 and y equals 13 minus x, then y minus 13 minus 6 is going to be 7. 13 minus 7 is going to be 6. And those are my ordered pairs. Oops. All right, those are my ordered pairs. That should be my solutions here, 6, 7, or 7, 6. Let's check them out in the original here. So if I come back to the original, it should work if they're switching places, both squares there. 36 plus 49 is going to give me 85 for both of them, because they would just switch places to be 49 plus 36, which is also 85. And we know that 6 plus 7 adds together to be 13. So there we go. Y squared plus 3x squared equals 37. Y squared minus x squared equals 1. I'll just solve to say y squared equals 37 minus 3x squared, and then make a substitution into the second one. 37 minus 3x squared minus x squared is equal to 1. So subtract 37 from both sides. Negative 4x squared equals negative 36. X squared is equal to 9. x is equal to -3 or x is equal to 3. When I do that, then we're going to come back to the first one and say y squared plus 3 times 9 is going to be 27. It's going to be equal to 37. Y squared is going to be equal to 10. Y is going to be equal to -√10, or y is equal to +√10. So I'm going to have 4 points of intersection that are going to be all the combinations of this, that I can have a -3 with a -√10, -3 with a +√10, +3 with a -√10, and a +3 with a +√10. Those are my 4 solutions to that system of equations. Now we're going to write an inequality in interval notation. The inequality is x is greater than 2. So here's my number line. I'm not going to draw all the numbers on the number line. There's 2. There's going to be an open circle, and I'm going to shade to the right. Next, we're going to graph x is less than 5. And put 5 on my number line. There's an open circle, and the arrow is pointing to the left. I'm going to shade to the left. Always put your x on the left-hand side. And the symbol is going to make an arrowhead that points in the direction that you want to shade in. If you have a greater than or equal to sign, like you have in the next one where x is greater than or equal to -3, we put a solid dot. We're still shading to the right, like this. It asks us to write interval notation and to graph the inequality. All right, let's back up. Let's do interval notation for these. X greater than 2 is going to be 2 to infinity. Then we're going to graph it. Okay. X less than 5. Going to be 5 for my upper bound that's not included, and it goes down to -infinity. And here's 5 coming this way. X greater than or equal to -3. It's going to be a -3 that's included to infinity. Here's -3, like so. Okay, that's the end of that page, that column. On to number 29. X less than or equal to 1. There's 1 included. We're going to shade down there. Now we're going to do some in-between ones. X is between 2 and 6 inclusive. So 2 and 6 are both included. Here's 2, here's 6. Solid dots for both. We're going to shade in between. -3 less than x less than 1. Neither are included. Got -3 over here, 1 over here. Both sides are open. I'm going to shade in between. For number 32, -3 less than or equal to x less than 1. So the left-hand bound of -3 is included, but the right-hand bound of 1 is not included. I've got -3 has a solid dot. 1 has an open circle, and I'm going to shade in between. And my last one is going to be written as 6 greater than or equal to x greater than or equal to 2, but I always want to write this with the smallest number on the left and the biggest number on the right. So that's really 2 is less than or equal to x is less than or equal to 6. So this is going to be the interval 2 to 6 with both endpoints included. This is 2 and 6, both endpoints included, and I'm going to shade in between. Now we want to solve an equation, a linear inequality equation here, and we're going to graph the solution set on a number line. So I have -4 times 2x plus 3 is greater than or equal to 2 times the quantity 4x minus 3 times x plus 3, like that. Left-hand side is -8x minus 12. That's going to be greater than or equal to 2 times 4x minus 3x minus 9. -8x minus 12 is going to be greater than or equal to 2 times x minus 9. -8x minus 12 greater than or equal to 2x minus 18. I'm going to get all my x's on the left-hand side. -10x minus 12 greater than or equal to -18. Add 12 to both sides. -10x greater than or equal to -6. Now I'm going to divide by a negative number. When I divide by a negative number, I'm going to need to change the direction of the inequality sign. So x is going to be less than or equal to, and we're going to simplify this to be 3/5. So here's 3/5 on my number line. Less than or equal to, I'm going to put a solid dot at 3/5, and we're going to shade to the left. Now we're going to have the absolute value of 10y plus 30 over 3. It's less than 10. I'm going to pull a 10 out front. Didn't multiply by any negatives because those were absolute values. There were no negatives there, so that means y plus 3 is between -3 and 3. Subtract 3 from everything. That means that y is between -6 and 0. Not included here because it wasn't or equal to. So on my number line, I'm going to have -6. I'm going to have 0. I'm going to have open circles for both. I'm going to shade in between. The distance here had to be less than. That's why it's between. If the distance was greater than, I'd have greater distances that would be on the outside, and I'd shade on the outside. But because this was a distance that was less than something, I'm taking the distances that are 3 or less away from the center point of this interval, which is at -3. So this says y plus 3, the center of this interval is at -3. We'll make this 0. The radius that I want there is going to be 3. -3 plus 3 is 0. -3 minus 3 is -6. I don't want to include the endpoints. (8k) plus 2 inside of absolute value bars plus 3 is going to be greater than 10. Absolute value of 2 times 4k plus 1 is going to be greater than 7. 4k plus 1 absolute value bars. It's going to be greater than 7/2. So now we have that distance is greater, like I talked about just a second ago. So we have negative 4k plus 1 is less than let's do it this way. Sorry. The inside here is either less than -7/2 or the inside is greater than 7/2. You can have it either way, that the absolute value is going to be bigger than 7/2 if it's less than -7/2 or greater than +7/2. All right, so I'm going to subtract 2/2, both sides. 4k is less than -9/2, or 4k is greater than 5/2, and divide both sides by 4. K is less than -9/8, or k is greater than 5/8. This is an or statement. So we have here's -9/8, open circle, less than, here's +5/8, open circle, greater than. See how it's disjoint. We're dealing with a union and not an intersection there. Now we're going to look at number 37. X squared plus 4x is less than 3x plus 12. X squared plus x minus 12 is less than 0. I'm going to make this x plus 4 times x minus 3 less than 0. I'm going to do a little sign chart here. It's going to be on my number line. Say here's -4, here's +3. When I have a number over here all the way to the right, it's a positive times a positive is a positive. Once I cross 3, this one's going to change sign, so it's going to be positive times negative is a negative. Once I cross -4, this one's also going to change sign, which will be a negative times a negative is a positive. I want my answers that are less than 0, so I don't want to include the zeros, and I want to shade in between. So my solution set is -4 to 3 in interval notation. They're showing you the graph here to help you, and they want you to see that the graph is negative and not 0. From -4 to +3, it's negative all down here. This is the area that I'm interested in, is between -4 and 3. So, but I wanted to show you the work. This is part of what we do in pre-calculus. We solve rational inequalities like this now, and polynomial inequalities like this. So this should be a prerequisite that you know how to do this by hand without the graph. Let's look at number 38. X to the 4th plus 15x squared minus 16 is greater than or equal to 8x to the 3rd minus 8x. We're going to get everything over to the left-hand side. X to the 4th minus 8x to the 3rd plus 15x squared plus 8x minus 16 is greater than or equal to 0. They've already shown the intercepts here to me and given a way that this factors as x plus 1 times x minus 1 times x minus 4 quantity squared. That's what that shows me, because it crosses, and then it touches there. So there's my multiplicities 1, 1, and 2. And there, let's see if there is a, there's not. The leading coefficient is 1, so there's no multiplier up front, but that wouldn't really matter here. So now we're going to look at our number line. We're going to say that this is -1, +1, 4, and this is cross, touch on the number line. Over here, it's positive. When I cross one of the boundaries where it touches, it's going to stay positive there. It did not change sign. Now it's going to cross and become negative. Now it's going to cross again and become positive. I want the places where it's positive, where it's greater than or equal to 0. So positive equal to 0, positive, equal to 0, positive. So my solution is negative infinity to negative 1 included, union 1 all the way to positive infinity because everything is shaded here from 1 all the way to the right. Okay. Now we have a rational inequality, 4x over x squared minus 4, and that needs to be greater than or equal to 0. So I have 4x over x plus 2 times x minus 2 greater than or equal to 0. My sign chart is going to be zeros at the top and zeros at the bottom. I'm going to have 0. I'm going to have negative 2. I'm going to have positive 2. I know that I've got asymptotes at negative 2 and positive 2. So they can't be included in my graph. I'm going to put open circles there right away. The 0 of the numerator is included because this says greater than or equal to. That's there. Now I'm going to, again, I don't have anything with a multiplicity of 2. It's crossing here at this place. I'm going to figure out what it's doing here. It's going to change sign as it crosses this boundary. So where everything on the right is positive, positive over positive times positive, it's positive. Then I'm going to have one sign change, and it's going to be positive over positive times negative, negative. Then I'm going to cross again, and it's going to be a negative over negative times a positive, that's positive. And then I'm going to cross again, and it's going to be a negative over a negative times a negative, it's going to be negative. So I want the places where it's greater than or equal to 0. That's going to be this positive area, and this 0. So that's going to be negative 2 to 0, union 2 to infinity. Number 40. Have negative 7 over x squared plus 3x minus 4 less than 0. So we're going to factor the denominator, x plus 4, x minus 1. Critical values are negative 4 and 1. You've told us, we just got that from factoring. So we have negative 4, we have 1, have open circles there. We're not going to have a sign change in the numerator. The numerator is always going to be negative. So when we have a negative over a positive times a positive, this is going to be negative because there's a forced negative in the problem here. Then we're going to cross the boundary. There's going to be one sign change. It's going to become positive. We're going to cross the boundary again. There's going to be another sign change. It's going to be negative. And we see that it was negative, positive, negative. And we want answers that are less than 0. So we want these negative regions here from negative infinity to negative 4, union 1 to infinity. Let's go ahead now and solve x to the 5th minus 4x to the 3rd greater than or equal to 0. X to the 3rd times x squared minus 4 greater than or equal to 0. X to the 3rd times x plus 2 times x minus 2 greater than or equal to 0. Put on a number line, negative 2, 0, 2. All of these are odd multiplicities because 1, 1, and 3 are all odd numbers. So it's going to cross at all of these. And we're going to start over here on the right. This is going to be positive, negative, positive, negative. It says or equal to. So we're going to include the zeros, and we want the positive regions because it says greater than. So my solution set is negative 2 included to 0 included, union 2 included to infinity not included. X to the 3rd plus 4x squared minus 16x less than or equal to 64. I'm going to bring 64 over to the left. X to the 3rd plus 4x squared minus 16x minus 64 less than or equal to 0. Factor by grouping here. going to have a repeated root of x plus 4. So we have -4 has a multiplicity of 2. It's going to touch there. +4 is going to have a multiplicity of 1. It's going to cross there. So we're going to start over here on the right-hand side where everything is positive. It's going to be positive. It's going to change sign when it crosses. It's not going to change sign when it touches. I want where it's less than or equal to 0. So that's going to be everything from -infinity to 4. I solve the rational inequality and graph the solution on a real number line. Express the solution set in interval notation. That's what we've been doing. So x plus 11 times x minus 8 in the numerator, x minus 1 in the denominator, greater than or equal to 0. So we have -11, +1, +8. 1 has to be not included because I can't divide by 0. I'm going to be able to include my zeros of -11 and +8. I'll put solid dots there. Over here to the right, I'm going to start with everything positive will be positive. I'm going to be crossing at these zeros. And I'm going to change sign when I cross that boundary because it's an even multiplicity as well. So this can be negative, positive, negative. I want where it's greater than or equal to 0. So I'm going to be from -11 to 1, union 8 to infinity. 1's not included, infinity is not included. Infinity is never included because it's an idea and not a number. Now we're going to determine the domain of some rational functions here. X to the third plus 4x to the fourth over x squared plus 81. I'm only concerned about the denominator and not the numerator. Can x squared plus 81 ever be equal to 0? The answer is no, because x squared can never be equal to -81 in the real world. So when I see an a squared, an x squared plus a squared in the bottom, then we're safe. It's not going to factor, and I'm not going to get any zeros from it. Let's go ahead and let's look at this denominator, 3x squared plus 6x minus 45. I'm going to pull the 3 out. This makes it x squared plus 2x minus 15. I'm not really worried about this 3. It's really the x squared plus 2x minus 15 part that can equal 0. And this is going to be plus 5 and minus 3. So x is equal to -5, or x is equal to 3. Those are my 2 bad points on my number line, -5 and 3, that I can't have. My domain is going to be everything else. So it's going to be -infinity to -5, union -5 to 3, union 3 to infinity. This last one here, 1 minus 8x over x to the third minus 12x squared minus 28x. We're going to pull out the common factor of x. X squared minus 12x minus 28. Factors of 28 that have a difference of 12 are going to be 2 and 14. The 14 is negative. The 2 is positive. X equals 0, x equals 14, x equals -2 are my bad points on my number line. So we have -2, 0, and 14. And then I want everything else. So 3 bad points is going to give me 4 intervals, -infinity to -2. Union -2 to 0, union 0 to 14, union 14 to infinity. Domain of these rational functions is going to be open intervals here. All right, now I want to find the domain of this radical function. F of x is equal to root negative 5x plus 6. So my rule for the domain of a radical function that has an even index is that the inside has to be greater than or equal to 0. It can't have a negative on the inside of an even root. So negative 5x is greater than or equal to negative 6. X is less than or equal to 6/5. So my domain is going to be 6/5 for the upper bound, negative infinity for the lower bound. I wanted that on a number line. Here's 6/5. Less than or equal to would be shaded to the left. Evaluate the expression if possible, 81 to the negative 5 force power. So I'm going to evaluate that by saying that that is 1 over 81 to the 5 force power is going to be 1 over 81 to the 1/4 power raised to the 5th power is 1 over 3 to the 5th. The 4th root of 81 is 3. 3 to the 5th is going to be 81 times 3 is 243, I believe. So let's just verify that with the calculator. (81) to the 5 force is 243, and it's a negative exponent, so it's 1 over that. There we go. Number 49. A to the negative 7 force over y to the negative 3/2 times y to the 1/7 over a to the 1/7. And that last fraction has a exponent of -1, and the first fraction has an exponent of 3. So this is going to be a to the negative 21 over 4, y to the negative 9 over 2 times y to the negative 1 over 7, a to the negative 1 over 7. So let's make positive exponents, y to the 9/2 over a to the 21 over 4 times a to the 1 over 7 for y to the 1 over 7. Let's get everything to have a denominator of 28 in the rational exponents here. So this is going to be 14. 9 times 14 is, wrong way, 14 and 9, 36. This is 126 over 28, I said, times a to the 4 over 28 over a to the 147 over 48 times y to the no, 28. Times y to the 4 over 28. Then I'm going to use my rules of exponents to say that bigger exponents in the bottom here, 143 over 28, and this is 122 over 28. Simplify those if I can. So the top is going to be 61 over 14. And the bottom is going to stay 143 and 28. There we go. We have x to the 5t over x, and that's going to all be raised to the 6th power. We want to simplify this. So it's going to be x to the 30t over x to the 6th. We can write that as x to the 30t minus 6. We would like to, because we have like bases. So nothing wrong with that. It didn't say that we had to have all positive exponents when we were done. So 51 tells us to factor t squared plus 2, I'm sorry, that's r squared, plus 2rs plus s squared minus 16. So I can only get s plus 4 and s minus 4 if I group these two together. I don't have any 4s over here, so I'd better find a different way of grouping them. Let's just do this. So this is going to be this first one here. Let's group this group of 3 and this group. This is an r plus s quantity squared. This is minus 4 squared, like that. So this is going to break down into r plus s minus 4 times r plus s plus 4. Some creative factoring, but I broke it down into a difference of 2 squares because the first 3 terms gave me a perfect square trinomial. 52 x to the negative 3a minus 5, and all that's raised to the negative 4th power. So that's going to be x to the 12a plus 20, and done. 53, we want to factor some more. 18x to the 3a minus 4x to the 2a plus 8x to the a. So we have a common factor of x to the a. We have a common factor of 2. So it'll be 9x to the 2a minus 2x to the a plus 4. X to the 2a is the same as x to the a squared. So I'm going to look at this like it's quadratic. In terms of the variable x to the a. Signs are the same and they're both negative. I'm not going to get factors of 36 that add up to be -2. So I'm actually done on this step right here, because these signs can't possibly add to something that factors anymore. So we're good there. Number 54. Q minus 4 to the second power minus 100 is a difference of 2 squares again. That's Q minus 4 minus 10 times Q minus 4 plus 10. And that's Q minus 14 times Q plus 6. X to the 6th minus 1. We need to do our difference of squares before our difference of cubes here. This is x to the 3rd minus 1 times x to the 3rd plus 1. Then our x to the 3rd minus 1 breaks down into x minus 1 times x squared plus x plus 1. And our x to the 3rd plus 1 breaks down into x plus 1, x squared minus x plus 1. So we have x minus 1 times x plus 1 times x squared plus x plus 1 times x squared minus x plus 1. These two quadratic factors at the end only have imaginary factors, complex factors. So if we were trying to solve this for zeros, we would only get real zeros from the first two factors. We're going to factor number 56 completely. X squared minus y squared plus 2y minus 1 is going to be x squared minus y squared minus 2y plus 1 is x squared minus y minus 1 quantity squared. So this is a difference of 2 squares, x minus y minus 1 times x plus y minus 1, and give me x minus y plus 1, x plus y minus 1. Now we have instructions to factor out the greatest common factor. Be sure that the coefficient of the term of highest degree is positive. X plus 5 times 3x plus 5 minus x minus 5 times 3x plus 5. So when we pull out the 3x plus 5, we'll be left with x plus 5 minus x minus 5. It's going to give me 3x plus 5 times x plus 5 minus x plus 5. X minus x is 0. This leaves me with 10 times 3x plus 5. I have 1/7 w to the 3rd minus 6 over 49 w. So we have a common factor of 1/7 w. It's going to leave me with w squared minus 6/7 like that. So that's going to be 1/7 w, w plus root 7 over 6, w minus root, I said 7 over 6, I meant 6 over 7, like that. I should probably rationalize that. Root 6 over 7 is root 6 divided by root 7 is root 42 over 7. So we're going to have 1/7 w, w plus root 42 over 7 times w minus root 42 over 7. So other ways we could have done this, I could have pulled out 1 over 49 and had a 7w to the third minus 6, but it would have given us the same answers. So we're going to factor this polynomial completely. X plus 4 quantity squared minus 5 times x plus 4 plus 6. Remember, I told you when I see repeated things like this that I'm going to do u substitution. So I see that u is x plus 4. So u squared minus 5u plus 6 is u minus 2, u minus 3. U was x plus 4. That's x plus 2 times x plus 1. Six times a plus 6 quantity squared plus 24. A plus 6 plus 18. Again, I'm going to use u substitution here where u is a plus 6. 6u squared plus 24u plus 18. I have 6 times u squared plus 4u plus 3 is 6 times u plus 1, u plus 3. U is a plus 6. A plus 6 plus 1. A plus 6 plus 3. 6 times a plus 7 times a plus 9. Now we're going to factor completely or state that the polynomial is prime. X squared times a minus b plus 81 times b minus a. A minus b and b minus a are opposites. So I'm going to change this into minus 81, a minus b, factor out a minus b, make this x squared minus 81, a minus b times x minus 9 times x plus 9. It's completely factored. And we're going to factor out the indicated common factor. We have 1 minus 8x to the negative first plus 12x to the negative second. They want us to factor out an x to the negative second. So I'm going to divide by x to the negative second, which is the same as multiplying everything by x squared. It's x squared minus 8x plus 12. Now they want us to keep factoring this, so we're going to write that over x squared. This is going to be x and x. Factors of 12 that add to be negative 8 are going to be negative 2 and negative 6. And we're done. We're going to do a whole lot of this in calculus because we need to get everything in factored form in the numerator and denominator. So we're going to factor out the negative exponents like this. So we can see the zeros of the numerator would be 2 and 6, and the zeros of the denominator would be 0. This is something very important in calculus. So we're going to have a few more problems like that. Q plus 3, negative 3 over 17, plus Q plus 3 to the negative 1 over 17, plus Q plus 3 to the 1 over 17. And they want us to factor out Q plus 3 to the negative 3 over 17, which is the smallest of the powers here. So Q plus 3 to the negative 3 over 17 is going to be 1 plus Q plus 3 to the positive 2 over 17 plus Q plus Q plus 3 to the 1 minus negative 3 is 4 over 17. And Let's go ahead and write this like so. Q plus 3 to the 3 over 17. I'm going to make a substitution here, but I want U to be Q plus 3 to the 1 over 17 power here for a second. So I'm going to call this denominator here U to the third. I'm going to make this numerator 1 plus U squared plus U to the fourth. So there are no factors of 1 that add up to the 1. So I'm done at that point. I just wanted to check and make sure that this didn't factor anymore before I wrote it in the nasty way that it was looking, that this is going to be, yep, that's it. We just wanted to factor it out. It doesn't say to write it as a quotient or to find zeros of it or anything like that. So we're done there. 4m plus 9 to the negative 2/5 plus 4m plus 9 to the 1/5 plus 4m plus 9 to the 7/5. And we want to factor out this most negative exponent here. 4m plus 9 to the negative 2/5 is going to give us 1. And then 2/5 plus 1/5 is 3/5. And plus 4m plus 9 to the 7/5 plus 2/5 is going to be 9/5. And we'll be done with that there. No reason to continue there. Expression that occurs in calculus is given. Factor it completely. 2x plus 4, x minus 3 to the third, plus x plus 4 squared times 4 times x minus 3 quantity squared. Okay, so we need to pull out the greatest common factor that we see, which is going to be 2x plus 4 times x minus 3 squared. So when we do that, we're left with an x minus 3 plus 2x plus 4 x minus 3 plus 2x plus 8 3x plus 5, and I factored it completely. I'm done with that one. 2x plus 1 quantity squared plus 3 times 2x plus 1 minus 4. We're going to factor out the 2x plus 1 and be left with 2x plus 1 plus 3. Sorry, get ahead of myself here. This is u equals 2x plus 1. This is u squared plus 3u minus 4. This is u plus 4, u minus 1. This is 2x plus 1 plus 4. 2x plus 1 minus 1 is going to be 2x plus 5 and a 2x on the outside. Let's look at this one. 3 times x plus 5 squared 2x minus 1 squared plus 4 times x plus 5 cubed 2x minus 1. Don't have any numerical coefficients that's in common, but we have 2x plus 5s that can come out, and we have a 2x minus 1 that can come out. That leaves us with 3 times 2x minus 1 plus 4 times x plus 5. That's going to leave us with x plus 5 squared, 2x minus 1. And that's going to be 6x minus 3 plus 4x plus 20. It's x plus 5 squared, 2x minus 1. 6 plus 4 is 10. 20 minus 3 is 17. And that doesn't factor anymore. On to 68. Just a few problems left. We have 49 minus x squared, it's the 1/2 power, plus 3x squared, it's 49 minus x squared, negative 1/2 power over 49 minus x squared, and that's the first power in the bottom. Want to get rid of that negative 1/2 power in the top, bring it to the denominator. So I'm going to factor out 49 minus x squared to the negative 1/2. That's going to leave me with 49 minus x squared to the first, because 1/2 minus a negative 1/2 is 1/2 plus 1/2 is 1, plus 3x squared over 49 minus x squared in the denominator. It's going to give me a 49 minus x squared to the, when I bring the 1/2 down, this is going to be the 3/2 power. Then we're going to have 49 plus 2x squared in the top, because 3x squared minus x squared is 2x squared. And that can't be factored anymore. So we've simplified it. We would be able to try and find zeros at the top and zeros at the bottom here. There would be no zeros at the top, but we've proven that. 6x to the 3/2, 3 x to the third plus x squared minus 8x to the 5/2 minus 8x to the 3/2. So we would like to pull out the greatest common factor. Before we do that, though, let's pull out this x squared. This is x squared is going to be x to the 4/2, and 6x to the 7/2 of x plus 1 minus 8x to the 5/2 minus 8x to the 3/2. I'm going to pull out x to the 3/2, and I'm going to pull out 2. So 2x to the 3/2 is going to leave us with 3x squared times x plus 1 minus 4x minus 4. It will be 2x to the 3/2, 3x to the third plus 3x squared minus 4x minus 4. So now we need to look at this. See if I can pull out 3x squared, x plus 1 minus 4 times x plus 1 is going to give me 2x to the 3/2 times x plus 1 times 3x squared minus 4. We're not done yet because that technically is a difference of 2 squares. So I need to factor it a little bit more, even though it's going to look a little crazy. This is 2x to the 3/2, x plus 1, the square root of 3x plus 2, the square root of 3x minus 2. All right. Last problem here is we have -5/2√6. We want to rationalize that denominator. So we're going to multiply by √6 over √6 is going to give us -5√6 over 2 times 6, -5√6 over 12. And that is all the problem. Oh, nope. Lied. Got more problems. Number 71, √11 over √3. We're going to rationalize this to be √33 over 3. Number 72, got -7 over 2√2 is going to be -7√2 over 2 times 2 is 4. Number 73, √3 over √5. We're going to multiply by √5 over √5. It's going to give us √15 over 5. Rationalize the denominator, assuming that all variables are positive. So we're going to have to multiply by some conjugates now. So we're going to have to multiply by 5 plus √5 over 5 plus √5. Be 15 plus 3 √5 over 25 minus 5. 15 plus 3 √5 over 20. That rationalized the denominator. Number 75, x minus 49 over √x plus 7. I've got a couple options here. I'm going to take one of the more interesting options to write this as √x plus 7, √x minus 7 over √x plus 7 and cancel out the √x plus 7s to write this as √x minus 7. Alternatively, I could rationalize the denominator by multiplying by √x minus 7 top and bottom. And when I do that, that's going to give me x minus 49 in the bottom, x minus 49 in the top, and a √x minus 7 in the top. And the x minus 49s will cancel, leave me with √x minus 7. I get the same answer both ways. Just take your pick how you want to look at that one. We're going to do some stuff with some h's, some h's. We use delta x's in the place of h here when we get to calculus, but same thing. 4 over √x plus h minus √x. Multiply by the conjugate of √x plus h plus √x over √x plus h plus √x, 4 √x plus h plus 4 √x over x plus h minus x is going to be 4 √x plus h plus 4 √x over h. Rationalize the numerator now. 7 plus √6 over 2. So we're going to have to multiply by its conjugate, 7 minus √6 over 7 minus √6. It's going to be 49 minus 6 over 2 times 7 minus √6. I'd leave it factored. It's going to give me 43 over 2 times 7 minus √6. So in the first couple of weeks of calculus, you'll know why you need to rationalize the numerator. 7x minus 4 or √7x minus 4. It's going to be 7x minus 16 over 11 times √7x minus 4. And that's it. now we're done. It's a long video. The other ones in the series shouldn't be as long as that, but there's a lot of Algebra 2 skills that you need in Calculus 1. I want to make sure to go over all these problems in one video for you. See you in the next video where we'll go over some stuff from College Algebra Part 1, Pre-Calculus 1. Have a good day.